Greetings, scholars. In this section, we'll be taking a look at solving exponential and logarithmic equations. I wanted to go back to the steps we had way back in the first half of the course for solving equations. You're going to see that the steps are exactly the same, but they might just look a little bit different how we manifest them. So I actually just want to go ahead and take a look at the example problem number 2 that is in your book that you'll actually see as you start to go through the example problems. The reason I actually want to do this problem is because I'm actually going to do it just a little bit differently than the book in a way that I think will make more sense to you and as it does to me. But let's go back to looking at our steps for solving an equation. Simplify, subtract, add, opposite sides, opposite operations, multiply, divide, dealing with exponents, and grouping symbols finally. Well, if we look at our equation, 15 to the power of 3x equals 285. As with all equations, we're trying to isolate the x. So if we start going through our steps, we can see simplifying, none of that. Add, subtract, none of that. Multiply, divide, well, right now, none of that. So now we can finally see what this exponent step will look like. We've got to do the inverse of this exponential equation. And what was that we were talking about in this section? That's a logarithm. So we're actually going to write this in logarithm form. Now I'm doing this differently than the book does. I'm just going to go ahead and write this as a logarithm. So log, my base, 15, log 15, the result that I would have gotten, 285, log base 15 of 285 equals 3x. Okay? Next, I'm going to deal with the fact, remember, our calculator cannot calculate anything in a base other than 10 or the natural number e. So instead of doing what the book did about taking the log of each side and everything like that, I think it makes much more sense to go ahead and write this log as you would, turning it into a logarithm from the exponential, and now use our change of base formula. If you recall from the previous section, our change of base formula says we're going to do this. We're going to write a log in a base that we can evaluate on our calculator. So I'm just going to use 10. That big number we're going to put at the top, log of 285. The small number we're actually going to use in the bottom, log of 15, equals 3x. So now that I've written like this, I can go to my calculator and punch it in. And once I do that, I get a result of approximately 2.087. Let's do one more decimal place. 3 when I round it. And that is approximate. Okay. So I've done my exponent step. No grouping step to do, but remember what we said in previous sections. When we do this, sometimes we have to go back to our beginning steps if we still don't have a variable isolated, and we don't. We still don't have any simplifying, we still don't have any add or subtract, but we do now have multiply, divide. The opposite of multiplying by 3, divide by 3. And once I do that, I get approximately 0.6958. So you can see we actually do end up with the exact same answer, just the process I think makes a little bit more sense with all you've been learning about logarithms. So that we just go ahead and write our exponential equation in logarithm form and then apply our change of base formula. So that's the basic idea of solving exponential equations. I do want to do one more type of problem before I send you forth through the rest of the lesson. So through the magic of editing, we'll have our new problem up here. And through the magic of editing, we're ready for our next example. Again, I just wanted to use an example from the book, so once you actually start looking through the section, you'll see this is example 5. I wanted to do this just again to emphasize how these steps from the previous section really do work in all these equations. So this time I've got a logarithm equation. So log of 4x minus 3 equals 2. So again, as with every equation, we're trying to isolate the x. So if we're looking at this, again, no simplify. No subtract, add for right now. No multiply, divide for right now. We're right to our exponent step. This, in this case, is actually written as a logarithm. But remember, it all switches back and forth. Logarithm, opposite is exponential. Exponential, opposite is logarithm. So we're going to now actually write this as an exponential equation. So we've got 10 to the power of 2. Remember, this base is understood to be 10, equals 4x minus 3. And I've now taken care of my exponent step. Grouping, no grouping. But now we come back up again, because still don't have x isolated, to simplify. We do have a simplify now. 10 to the second power is 100. And keep on writing the rest of our equation. Add, subtract. We do have an add, subtract now. Opposite of subtracting 3, add 3. We have a multiply, divide. Instead of multiplying by 4, we're going to divide by 4. And that gives us 25.75. And we now have x all by itself. So continue through the lesson, and good luck solving those exponential and logarithm equations. Good luck, scholars.